Let us discuss the one more problem. A string of length L is fastened at both ends. The midpoint of the string is taken to a height h and then released from rest in that position. Find the displacement function yxt. This experiment also satisfies all the assumptions of the wave equation. Therefore, the displacement function yxt satisfies the one-dimensional wave equation dou square y by dou t square is equal to c square into dou square y by dou x square. Together with the boundary conditions that y of 0t equal to 0 and y of lt equal to 0, which means that there is no displacement at the point x equal to 0 and at the point x equal to L. Now, the initial conditions are not given, but the information to find the initial conditions are given. Let us read the second sentence. The midpoint of the string is taken to a height h and then released from rest. Now let us consider the picture of the tied string. O and B are the end points of the string. At the midpoint of the string, that is at x equal to L by 2, the string is moved to a height h and released from rest. Now, the Cartesian point of the beginning point O is 0, 0 and the end point B is L 0. The Cartesian point of the midpoint is L by 2 0 and the Cartesian point of the A to which the string is changed is given by L by 2 h. The distance along x-axis is L by 2 and it is moved to a height h from the x-axis. Therefore, the value corresponding to y is h. Now, yxt denotes the displacement. Let us, now the string is at a position of the line OA when x lies between 0 and L by 2 and when x lies between L by 2 and L, the string lies on the line AB. Now, the value of the function y of x when x lies between 0 and L by 2 is given by equation of the straight line OA. To determine the equation of the straight line OA, let us use the standard equation to find a line joining x1 y1 and x2 y2. The equation is given by y minus y1 divided by y2 minus y1 is equal to x minus x1 divided by x2 minus x1. Here we have taken x1 is equal to 0, y1 is equal to 0, x2 is equal to L by 2 and y2 is equal to h. Substituting the values of x1, y1 and x2, y2 in this expression, we get y1 is equal to 0, y2 is equal to h, x1 is equal to 0 and x2 is equal to L by 2. We have the expression y minus 0 divided by h minus 0 is equal to x minus 0 divided by L by 2 minus 0, which can be simplified as y by h is equal to x by L by 2. Multiplying the right hand side by the reciprocal of L by 2, we get y by h is equal to 2x by L, from which we will get y is equal to 2hx divided by L whenever x lies between 0 and L by 2. Now, the value of y of x when x lies between L by 2 and L is on the line AB. The equation of the straight line AB is determined by using the equation of the straight line joining x1 y1 and x2 y2 again. The value of x1 is L by 2, value of x2 is L, value of y1 is h, value of y2 is 0. the equation y minus y2, that is, sorry, y minus y1, that is y minus h divided by y2 minus y1, which is 0 minus h, is equal to x minus x2, sorry, x minus x1, that is x minus l by 2 divided by x2 minus x1, that is l minus l by 2, which is given by y minus h divided by minus h is equal to x minus l by 2 divided by l minus l by 2 is L into 1 minus 1 by 2, that is L into 1 by 2, which is L by 2. Therefore, the denominator becomes L by 2. Multiplying by the reciprocal of L by 2 the right hand side, we get x in 2 into x minus L by 2 divided by L. Now multiply throughout by minus h, we will get y minus h is equal to minus 2h by L into x minus L by 2. Opening the bracket, we will get minus 2hx by L plus 2h into L divided by L into 2. 2 will be cancelled, L and will be cancelled, and we will get the second term as h and the first term as minus 2hx by L. Now transforming minus h from left to right, it will become plus h, and we can simplify the term as y is equal to 2h minus 2hx by L. If I take 2h by L outside, then the term can be simplified as 2h by L into L minus x whenever x lies between L by 2 and L. Therefore, the initial condition or initial displacement when time t equal to 0 is given by f of x, which is at the position OA and then AB, which is given by 2hx by L when x lies between 0 and L by 2, and 2h by L into L minus x when x lies between L by 2 and L. Now, since the initial velocity, the since the string is released from rest, we can say that initial velocity is equal to 0. Therefore, dou y by dou t at the time t equal to 0 is 0. The general solution of the wave equation by the method of separation of variables is given by yxt is equal to c1 cos px plus c2 sin px into c3 cos cpt plus c4 sin cpt. Let us apply the first boundary condition that y of 0 t equal to 0. When we substitute y of x is equal to 0 in equation 6, we obtain c1 is equal to 0. Then equation 6 implies yxt is equal to c2 sin px into c3 cos cpt plus c4 sin cpt. Now, when we apply the second boundary condition that y of lt is equal to 0, we will get c2 sin pl is equal to 0, from which we will get p is equal to n pi by l for n equal to 1, 2, 3, etc. Now, applying the uh, so applying the boundary conditions and the superposition principle, the general solution reduces to yxt is equal to sigma n equal to 1 to infinity an cos n pi ct by L plus bn sin n pi ct by L into sin n pi x by L, where an is calculated by the formula 2 by L into integral 0 to L f of x into sin n pi x by L dx, and bn is calculated by the formula bn is equal to 1 by 2 pi c into integral 0 to L g of x into sin n pi x by L dx. The derivation of this equation is explained in the previous video. Now let us substitute the value of f of x over here. To substitute that, first we should split the integral from 0 to L, because f of x is splitted at the point L by 2. F of x is splitted at the point L by 2. Therefore, the integral also should be splitted at the point L by 2. Then integral 0 to L can be written as integral 0 to L by 2 plus integral L by 2 to L. then the value of an becomes 2 by L into integral 0 to L by 2 into f of x when x lies between 0 and L by 2 is 2hx by L into sin n pi x by L dx plus integral L by 2 to L f of x in the interval L by 2 to L is given by 2h by L into L minus x into sin n pi x by L dx. Here the first term is a polynomial, therefore we apply UV rule of integration. According to UV rule, integral UV dx is equal to UV1 minus U dash V2 plus U double dash V3 minus etc., where dashes denotes the derivatives and the suffixes denotes the integral with respect to x. Now evaluate the first integral as 2h by L is a constant in the first integral. We have take it outside. Then the remaining integral is integral x sin n pi x by L dx. Let us take x as u and sin n pi x by L as v. Then applying the UV rule, we will get UV1. U is x itself. V1 is integral of v, that is integral of sin n pi x by L dx. Integral of sin n pi x by L dx is minus cos n pi x by L divided by derivative of n pi x by L, that is n pi by L. Therefore, V1 is minus cos n pi x by L divided by n pi by L. Minus is taken from the UV rule, minus u dash. U dash is the derivative of u. Derivative of x is 1 into V2. V2 is the integral of V1. Now, integral of V1 is integral of minus cos n pi x by L divided by n pi by L dx, which is given by minus L by n pi, or we can write it as minus 1 by n pi by L into integral of cos is again sin n pi x by L divided by n pi by L. This minus is here. Now sin n pi x by L divided by n pi by L into n pi by L becomes n square pi square by L square. Now the next term is plus u double dash. U dash is 1, a constant, therefore u double dash is going to be 0. Therefore we can stop the integration of the first integral over here. Now let us evaluate the second integral. To evaluate the second integral, 2h by L is a constant that can be taken outside. Then L minus x is the first function. Let us call it as u, and sin n pi x by L is v. Then apply the UV rule. The constant 2h by L into u in u, that is L minus x, into v1 is integral of v1 is same as in the previous case, that is minus cos n pi x by L divided by n pi by L minus u dash. U dash is the derivative of L minus x with respect to x, that is minus 1 into V2. V2 is the integral of V1, which is same as in the previous case. Again, plus U double dash. Since U dash is minus 1, which is a constant, U double dash is going to be a constant. Therefore, here also we can stop for the evaluation of second integral. Now, let us simplify the terms so that the evaluation is easier. Let us take the constant 2h by L outside. Then minus and n pi by L has been taken outside, and it will become minus L by n pi into x cos n pi x by L. Limits should vary from 0 to L by 2. Minus into minus plus. Reciprocal of this term is L square by n square pi square into sin n pi x by L varies from 0 to L by 2 plus next term 2h by L into, here also this minus L by n pi can be taken outside, into L minus x into cos n pi x by L varies from L by 2 to L minus minus minus. The product of three minuses is going to be minus into the constant term becomes L square by n square pi square into sin n pi x by L varies from L by 2 to L. Now let us apply the limits. When I apply the upper limit, the term 2h by L is common on both the terms, which can be taken outside. Now let us evaluate the first term, minus L by n pi into, apply the upper limit, then I will get L by 2 into cos n pi by 2 minus 0 into cos 0. 0 into something is going to be 0, therefore I have 0 plus L square by n square pi square into sin n pi by L into sin n pi by L into L by 2. L will be cancelled and I will get sin n pi by 2 minus sin 0. Sin 0 value is 0. Now next time minus L by n pi into, apply the upper limit, L minus L is going to be 0. Then apply the lower limit, L minus L by 2 is going to be L by 2, then minus L by 2 into cos n pi by L into L by 2. L will be cancelled and I will get cos n pi by 2 minus L square by n square pi square into, apply the upper limit, then I will get sin n pi by L into L will be cancelled and sin n pi is equal to 0. Therefore the term becomes 0 minus sin n pi by 2, which is obtained by sin n pi by L into L by 2. L will be cancelled and it will become sin n pi by 2. Now let us simplify these terms. The product of all the constant terms becomes 4h by L square. Now first term becomes minus L square by 2 n pi into cos n pi by 2 plus L square by n square pi square into sin n pi by 2 minus L by n pi into minus L by 2 becomes plus L square by 2 n pi into cos n pi by 2 minus into minus plus L square by n square pi square into sin n pi by 2. Here minus L square by 2 n pi into cos n pi plus L square by 2 n pi into cos n pi are the same terms but opposite in sign. They will be cancelled out and the second and fourth terms are same. Therefore they can be added. They will be added to 2L square by n square pi square into sin n pi by 2. Now L square and L square will be cancelled out. On simplification we will get 8h divided by n square pi square into sin n pi by 2. Now we have to evaluate Bn also. The equation of Bn is given by 2 by n pi c into integral 0 to L g of x into sin n pi x by L dx. This is equal to 0 since the initial displacement function dou y by dou t at time t equal to 0 was given as 0 because the string is released from rest. Therefore, Bn is equal to 0 for all n. Now, the general solution of the wave equation is given by yxt is equal to sigma n equal to 1 to infinity an value is 8h by n square pi square into sin n pi by 2 into cos n pi ct by L plus Bn is 0 for all n, therefore I can write it as 0 into sin n pi x by L. Now it can be simplified as sigma n equal to 1 to infinity 8h by n square pi square into sin n pi by 2 into cos n pi ct by L into sin n pi x by L, which is the required solution.